So briefly, to explain the details of this information, if we were to interpret these values, we know that C equals 1.5, which is the initial value, which in this case is the number of donors in the initial year. The value of B is the initial rate of change. So 0.42 what? Well, it's the change in Y over the change in X, and the Y measures the millions of donors, and this measures the number of years. So we would have million donors per year initially. That's the initial growth rate. But then what happens to that rate of change? Well, the rate of change is growing or decreasing by twice the value of A, which would be 2 times negative 0.007, or about negative 0.014. So that means that every year this guy is going down. That growth rate is negative 0.014 less. So that would basically continue to decrease. So the amount of growth gets smaller and smaller, and hence we start to see something like this happen. And assuming that this continued forever, if that rate of change continued to decrease, then eventually it would come back down. Now let's look at the next part, in which case we will go back to a linear regression. The number of people needing this particular blood type is a function of years after 2000. Create a linear regression for this data. Okay, so now these are people who need the donors, and we see that that's decreasing over time. Okay, now the decreases are, if you'll notice, approximately constant. 0.02, this is down 0.03, then it goes up 0.01, and then it goes down 0.02. So the number of donors fluctuates kind of linearly, and it goes down 0.03. So it's approximately linear, and it's not really quadratic since the rates of change aren't getting consistently smaller or bigger. So we'll model these. And here are those values. I've just changed my list 2. I left list 1 the same because they're the same input values, they're just different output values. And now I would go over to stat, and I'd go over to calculate, and I would do, in this case, linear regression, and I would press enter. And there's my equation. So the number of people needing donors is decreasing by 0.008 million per year. And in the initial year, we estimate, based on the equations, there were about 4 million donors, which is about accurate. Remember, there's a little bit of error in this process. So I would go over to my y equals, and now I'm not going to delete the quadratic one. I'm going to leave that in there because we're going to look at them together. So for my y2, I would go to vars, down to statistics, over to EQ, and pick reg EQ, and now it enters the most recent regression I've done. So if I did zoom 9, I would be able to see the points. So first of all, I'm still seeing my parabola, but there's the people needing donors data. And okay, so now I can make my prediction. It says, well, create a linear regression for this data. The final question is, in what year will the number of donors be the same as the number of people needing this blood type? Now you'll notice that these are both measured in millions of people. I'm going to adjust my window just a little bit. Whoops. My window, I'm going to go from, now this is years, so I'll go from 0 to 13.2 years, and I'll adjust the donors from 0 to about 5 million. That should give me a pretty good image of everything. Okay, so there's that one. There's my data. I can now turn off my stat plot. I no longer need that. All that will do is just make the data points go away, because now I'm just using the mathematical models. Now, this question asks, in what year will they be the same? Well, from what we know from previous studies is that it's anywhere there's an intersection point. Well, is there only going to be one intersection point? If these were both lines, then yes. But this guy is going up slowly, 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 and eventually will come back down. So what I'm going to do is I'm going to, and you can just do zoom out if you'd like, zoom out in the middle of the screen, and it should give you a more solid image of that graph. So you see that somewhere over here there's going to be another intersection point. So the number of donors is going up, is anticipated to drop back down. The people needing donors is consistently decreasing, and so I adjust my window, maybe go out to like maybe 30 years, and I should be able to get a whole holistic image of